Here are the directions. The speed of a car driving along a straight highway is given at different moments over a 2-hour period. Okay, and we have this little table of values. We are given time in hours, 0, quarter hour, half hour, 1 hour, and so on, up to 2 hours. And then the velocity of the car, or the speed of the car, at those different points in time. So 60, 65, 55, 60, so on. And then what we want to do is to estimate the displacement of the car by using a midpoint Riemann sum with n equals 4 rectangles. Okay, so one of the key facts you need to know here is that displacement can be found by calculating the area under the velocity curve. Okay, so then what we're going to do is we're going to approximate displacement by approximating the area under the velocity curve. Now, unlike the problems we've done before, we've done Riemann sum examples before, right? But we always had a function. Here we don't have a function. We have a few values. So we'll approach this a little bit different way. Okay, so this is a midpoint Riemann sum. So let me write down then the formula for the midpoint Riemann sum. Okay, so if you want to find a midpoint Riemann sum, okay, this is what you're going to be doing. The sum from k equals 1 to n of f of a plus k plus k minus 1 over 2 times delta x, and then all that times delta x. Okay, and this is what we've seen before. Now, what we're actually finding in this case is displacement, right? So this is going to give us our displacement approximation. And what's f in this case? Because we don't have a function. Well, we're just going to use values from our table. Okay, so f in our case represents the velocity function. Okay, and we don't have that in algebraic form, but it's okay. We have a table of values from that function, so we can still do the problem. Okay, so let's approach this like we have in the past. Let's try and figure out what each of these pieces are, and then we'll plug and chug. Okay, so the directions say to use 4 rectangles. Okay, so n equals 4. Now we said f was going to come from the table. That's our velocity function. A is the left-hand endpoint of our region. So we're doing this over a 2-hour period. So the start is just 0, right? The left-hand endpoint is just 0. Okay, k is our index of summation. Delta x is what it always is, b minus a over n. So here we're going from 0 to 2 hours. So 2 minus 0 over 4, or 1/2. Okay, so let's plug this into our into our displacement formula, this midpoint Riemann sum. So I'm going to call this D for displacement. It's going to equal the sum from k equals 1 to 4, f of 0 plus, okay, k plus k minus 1 is 2k minus 1 over 2 times delta x, which is 1/2. And then times this other 1/2. Now this 1/2 I can bring out front because it's a constant multiple. So if I do that, I get 1/2 times the sum of f of 2k minus 1 over 4. Okay. Now typically what we would do next, right, is we would have a function like x squared. And we take this and plug it into the function. And then we do a bunch of algebra and try to get things into k squareds and k's and constants so that we could use our sum formulas to get a final numeric value. But here we don't have an algebraic function, so that's not going to work. So what we're going to do is we're going to break out the sum. Luckily, we're only doing this for 4 rectangles. So there's not too many pieces to do because I really just have to add these by hand. Okay, so what do I mean by that? So I just am going to plug in k equals 1, 2, 3, and 4. Okay, so if I plug in k equals 1, I get f of 2 times 1 minus 1 over 4. Okay, if I plug in k equals 2, okay, so this is k equals 1. If I plug in k equals 2, I get f of 2 times 2 minus 1 over 4. Okay, k equals 3 gets me f of 2 times 3 minus 1 over 4. And 4 gets me f of 2 times 4 minus 1 over 4. Okay, so I'm just doing the sum, right? Doing it out long ways. So if I simplify these a bit, 1/2 is still up front. This is f of 1/4 plus f of 4 minus 1, so 3/4, plus f of 5/4 plus f of 7/4. Okay, now as decimals, that's f of 0.25 plus f of 0.75 plus f of 1.25 plus f of 1.75. And now, to finish this out, I just need to read off those values from my table. So remember, in our case, this f is our velocity function. So f of 0.25 is 65. F of 0.75 is, oops, I forgot a value on our table. Alright, sorry about that little typo, so I filled that back in. So at 75, or 0.75 hours, we were going to 70 miles per hour, so 70. Plus f of 1.25, that one is 45. Plus f of 1.75, which is 70. Okay, so if you plug that into your calculator, you should get a final value of 125. Units are miles. So the displacement is 125 miles. That's the net difference in your starting point and your ending point. So this is how you, first of all, approach a displacement problem. Okay, so displacement is the area under the velocity curve. And second of all, this is how you can approach a Riemann sum problem when you're given a table of values instead of a function.